The Black-Scholes formulas are somewhat complicated, and if one looks at them, you can see that here's the value of a call. Notice that the call price reflects all of the parameters, and we should now understand what each of these are. S is the price, K is the strike, sigma is the annual volatility, R is the annual risk-free rate on a continuous basis, T is the expiry time, and delta is the continuous dividend rate paid by the stock. And what we see is that the call, and it's descriptive the way the formula can be understood, and that is that it'll turn out that this expression is the delta of the option. It isn't at all obvious that that's true, but I'll just jump ahead a little bit to say, when you look at the Black-Scholes formula, it tells you the replicating portfolio. It tells you that the value of the option is delta shares, and that expression is delta, and you have to be short, and this is the T-bill with an accumulation factor. So what we have is that the value of this option is the value of delta shares, and this is our new T-bill position. And then by going long shares, short T-bills. So notice that the T-bill position is this entire expression, and and so what is the rest of the terms? Capital N, I'll talk about it in a moment. It's the normal distribution function. But notice D1 and D2 are simply points that one can evaluate the normal cumulative distribution on. Notice that D1 reflects SK, R delta, sigma, and T, reflects all the parameters of the option, and D2 is D1 minus one period vol, the volatility of one period. Notice the put option formula. Again, one can look at the delta of a put. It's right here. That's delta. So in the put option, again, we have B. This is B. It tells us the T-bill position is the first term. We'll go long T-bills for the put, and we short delta S, and that's our replicating portfolio. So the Black-Scholes formulas not only provide you a price, but they give you visually the replicating portfolio for this option in continuous time. So the notation, I've already described it, but just a quickly review. In some formulas, S is denoted S0 to indicate that we're calculating the value of the option at time 0. K is the strike. Sigma is the annual volatility. So if T is denominated in time, sigma squared is the variance of the log ratio of prices 1 year apart. R is the continuous risk-free rate. T is the term in years. And in some formulas, you'll note that the time T is called T minus little t, so that the model is that we're pricing at time little t, expiration is at time capital T, so that the term of the option is capital T minus little t. When you do that, then in the S will then be called S sub little t. So the formula changes a little bit, but it's pretty easy to understand the connections. And finally, delta is the continuous dividend yield. So recall the normal distribution, which is discussed more in Appendix A of this chapter. The normal probability density is this highly symmetric, this is what's sometimes called the unit normal. And it's the unit normal because it has a mean of 0 and it has a standard deviation of 1. And this is the probability distribution that we're all familiar with as an error curve. And it's a probability distribution that one finds numerical values associated with in the back of virtually every statistics book. There'll also be a normal distribution table given out for this exam, which is in the study materials. The cumulative distribution function is the total probability up to x. So if I pick any x, capital N of x is the total distribution up to x. And this is really what's in most normal tables. Typically, what a normal table will give you is the integral from 0 to x, and then you're expected to know that you need to add 1/2 to that to get n of x. You can also calculate this normal distribution in Excel using the norm S distribution, standing for the standard normal distribution function. So if you just plug that in, it'll give you these integral values approximated reasonably well. So this distribution can be called the unit normal. Sometimes it's called the standard normal, variety of names.